Yes, sir. Made you as a host. You can start the session.
Okay, thank you. Hi guys, is anybody yet to join or shall we start? Or we can wait for a couple of minutes. Am I audible first of all?
Yes, sir, audible, sir.
Okay. Anybody yet to join or everybody has come? Okay, thank you. Yeah, the problem with this course is that, as you know, we're in the initial stages, so they might not get any problem, but okay, let's join. Let's continue our topic. Is it visible?
Sir.
Yeah,
Yes, sir.
okay, thank you. Okay, I think yesterday we have stopped somewhere. Yeah. Yesterday, I think we are discussing about this problem. Right? And to see the indeterminacy of this frame. Now, first of all, let us try to discretize this into different parts. Okay, suppose let's say I will discretize till here, discretize till this point, I will discretize till here, I will discretize till here, I will separate or I will discretize. So let us divide this entire frame into number of parts and then let us see how we can understand. So this is what our first part, let us say. And I think this is what our second part. And this is what is our third part. Fourth one. Fifth one. And then finally, our final thing. Okay, what we have done is that we have just divided this entire frame into different parts. Now let's see. Now, coming to this part one, how many reactions will develop at this support?
Each 3.
Here 3, right? Now, what about at this end? As we are separating it from the frame, and here also how many reactions will develop? How many reactions will develop at this end?
Which end, sir? The first number end. Same only, sir.
3, isn't it?
Yes,
now,
sir.
Now find out how many extra equations we need in this part. How many unknowns we are having? 6.
6.
If this entire frame is stable, then obviously this will also be stable. Then for this part also, how many equilibrium equations we have? 3. So 6 minus 3. So total for this, how many unknowns we have?
3.
3.
3.
Right? Now, let us assume, let us keep these 3 aside and let us assume that this 3 is known and this 3 is known. Already in our hand, how many additional equations we are having? 3. Let us say we have those additional equations and then we have find out these 3 unknown and these 3 unknown plus. Now tell me, if these 3 are known, can I know these 3?
Yes,
Yes,
sir.
sir.
I can write?
No, sir.
No.
Yes.
If I separate at any one point, then we already discussed, right? As suppose, let us say, if you are talking about this point A, and if we separate it, equal and opposite reactions will exist, isn't it? In the same way, if I know these three, I know these three. Now, similarly, at this point, how many unknown forces will be there? At this end,
Three.
three. As I'm
sir.
separating it, three.
Three.
Similarly, at this point, how many will be there?
3.
Three, right? Now, already these three are known, isn't it? This is known value.
Yes.
Yes, sir.
So total, how many unknowns are there in this part?
6.
3 plus 3, 6.
Unknowns.
Then again, if it is to be
Yes, sir,
unstable,
6.
it has to satisfy equilibrium equations. Then 6 minus 3. Again, what is the indeterminacy for this part again?
3.
3, isn't it? Now, come to here. Now, let us say again, I am adding this into the number of equations list. Now assume that we have those additional 3 equations, and then we have found these forces also. That means this is known, this is also known. We are imagining that. And then here, how many reactions will exist?
3.
3. If this is known, may I know this or not?
Yes, sir.
Yes, sir.
Then, okay. Now, how many equations will exist here?
3.
3.
Now, total, how many unknown forces are there here?
3.
3. How many equilibrium equations?
3.
3. That means this part is no additional equations are
0.
required. That means this might can be also found. Now, here, how many will exist? 3.
3. That is known.
This is also known. So this is also known. Now, at this, how many reactions will exist? 3.
3.
Now again apply equilibrium equations here. How many unknowns are there? 3. How many equilibrium equations? 3. Now remain indeterminacy 0. That means if this 3 is known, this is also known. If this 3 is known, I know this 3 too. Right? Now come to here. If this 3 is known, I know this 3 too. Isn't it? That means at this point, how many will exist? Again, 3. Total, how many unknowns will be there? This 3 is known, this is known.
3.
This 3 is known, this is known. So how many will exist? 3. That means 3. How many equilibrium equations? 3. That means equal to 0. If this is 3 is known, then obviously at this end, these 3 can be known. Now here, how many reactions will exist? 3. Now total, how many unknowns are there? 3. If I apply equilibrium equations, 3 minus 3, 0. That means if I can able to find any 6 unknowns, then what I can say, I can solve all the forces in this frame. So this, I will say this as the total indeterminacy of the frame. As we have already discussed, indeterminacy can be divided into internal indeterminacy plus external indeterminacy. From the support, you can understand, right? Suppose if you look at the supports itself, look at the entire frame. 3 will exist here, 3 will exist here. So from this, you can directly know the external indeterminacy is total unknown 6, 6 minus 3, 3. That means out of these 6, 3 will be external indeterminacy and remaining 3 will be internal indeterminacy. That means if you want to find out what is the total indeterminacy, irrespective of whether it is external, whether it is internal, what you can start with is that divide the entire structure or entire frame into number of parts and then try to obtain number of unknowns in each part and then sum it up. That is what your nothing but your total indeterminacy. Is there any doubt in this task how we have solved it into different parts and then we have obtained the total indeterminacy? You guys want to explain this for one more equation, one more problem? Sorry guys, again the same problem. Whatever you guys are saying, I'm unable to understand properly. So you can type it. My voice is clear, isn't it? There is no issue about it, right?
Yeah, clear, sir.
Okay, thank you. Shall we discuss the same topic with another case? Yeah, Ramya, in case if the fixed end is replaced by in support. Okay, let's solve in that case. Let's see another problem, let us say. In this case, let us start with simple case, okay? Imagine there is somewhere hinge around this point. Now, first of all, I think this we can solve it. Directly, can you guys tell me what is the indebtedness of this frame?
One.
Is it one?
Did you
Everybody
make
agrees with that?
Determinate, sir. Zero.
Zero, isn't it?
Zero,
Why?
zero,
Because
sir.
total support reactions are 4.
4.
Why? Because here it is 2, here it is 2, right? 4 minus 3,
2, 3.
1. That means we also having the additional hinge here. So how many members are connected at hinge? 2.
2.
That means how many extra equations we have? 2
1.
minus 1, that means 1.
One.
So this is a determinate case, right? So let us try to obtain with the same whatever we have discussed earlier. So let us say we have separated at this point and we have separated exactly at the hinge point and then we have separated it here. Okay, now now coming to here, let us say, let me write here, A, B, C, D. Now at end here, how many reactions will exist?
2.
How many?
2.
2. And at this
At
point, at this end, how many? 3 will exist. So total how many? 2
Five.
plus 3, 5.
5, sir.
5 minus 3, that will be equal to 2. If these 3 are known, then I know about these 3, isn't it?
Yes, sir.
And how many reactions will exist here?
3, sir.
3 then, sir.
2?
I am this cutting exactly at the hinge point.
No
If it is-
moment.
No,
So
sir. 2, sir. 2, sir.
Yeah, 2. As it is the hinge, there won't be any
Moment.
internal resisting moment. So that's why moment will be equal to 0. So here how many reactions will exist? There will be some axial force and also there will be some vertical force. How many will exist?
2, sir.
2. Now tell me, if these 3 are known, these 3 can be known or not?
No, sir.
Right? Now how many unknowns are there in this case then?
2 unknowns.
2 unknowns. Then how many equilibrium equations?
3.
3.
2, sir.
No, see. Equilibrium equations will not change at all. It doesn't matter whether it is a hinge or it doesn't matter. Only thing you have to see is that if you are taking equilibrium of a point or you are taking equilibrium of some section. If it is the equilibrium at point, we have already discussed. If it is at a point, what happens? Movements are not generating. So that's why we'll have only 2 equilibrium equations. That's why if all the members are meeting at one point, you will consider only two equilibrium equations. If we are taking a section, as moments will also generate, how many equilibrium equations you have to consider? 3. Now is it clear? 2 minus 3. Now what is the indeterminacy here?
-1. Unstable.
That means we are having one extra equation, isn't it?
Yes, sir.
So already we need 2. So what I should do? I should do 2 minus 1. That means what is the net value have become? 1.
1.
Now tell me here how many will exist? Here how many will exist? 2 or 3?
2, 2, 7.
See, don't guess any answers. Why? Because here if you guess the answer, it's not the final exam that I can give you some marks. So whatever you guys will say, just say it with the clear mind. If you guys are not getting, just let me know. We will explain. But don't
Two,
guess it. 2.
2,
Right.
sir. 2, sir.
2. Now how many will exist here?
3.
3.
Sir.
3,
So these two already known, isn't it? If these two is known,
Yes, sir.
this two is already known. So total how many unknowns?
5.
3. 3 minus 3,
Yes,
0.
sir.
If these 3 are known, can I know these 3 are not?
Yes, sir.
These 3 are known. How many will exist at point D?
2, sir.
2. As it is a hinge support, 2 will exist. As this 3 is known, this 3 is also known. So how many unknowns are there?
2 unknowns.
How many equilibrium equations again?
3.
3. How many additional
Minus
equations? Minus 1.
Minus
So again, if I add minus 1 here, what is the indeterminacy? So is it clear as of now about this
Yes.
methodology, how we should go by part? But what is the thing is that here we cannot obtain separately what is the indeterminacy. Right. We are looking up the entire frame, or we are looking into the parts. So that's why you may not directly know what is the external indeterminacy or indeterminacy. But with the application of this problem, I will say that if you want to find the internal indeterminacy, you have to look up how many number of loops are there. How many number of closed loops. Closed is very important. So if you want to find a shortcut, so this is what is. You have to see how many number of closed loops are there. In this case, tell me how many closed loops are existing.
1, sir.
1.
1.
So, isn't it? If there is one closed loop, so as it is a 2D frame, right? If it is a 2D frame, how many internal forces will exist? If it is a 2D frame, 3 internal forces will exist. If it is a 3D frame, how many forces will exist?
6, sir.
6 will exist. So as it is a 2D, 3 internal forces will exist times how many closed loops are there? 1. That will be equal to, so now what is the indeterminacy? Internal indeterminacy is 3. So just look at the problem. You can say DSC, you can directly find out from the supports, and then internal, directly you can see how many closed loops are existing, and then just add these two values. That is what your total indeterminacy. Now is it clear with respect to some shortcut and with respect to the logic? Any doubt in these two cases? If not, then we'll continue with one more example.
Cleared, sir.
Okay, now tell me what is the answer for this case. That is What is the external indeterminacy?
Four minus
External indeterminacy, you can look into the supports. At A we have 3, at B we will have 3. So total 3 plus 3, 6, 6 minus 3, 3 is the external. Now come to the internal indeterminacy.
3, sir.
3 why? Because how many closed loops are there? Only one closed loop is there.
Sir.
one, sir.
As it is a 2D frame, 3
Yes,
internal
sir.
forces will exist on how many closed loops?
1,
1. So total indeterminacy is 3.
3, sir.
Total indeterminacy is nothing but a 3 plus 3, that will be equal to 6. Right? What if the problem is like this? What is the indeterminacy?
3, sir.
3, sir. There is no
3. Why? So total, you guys are saying
There is
total
no
indeterminacy. Tell me about internal indeterminacy.
total determinacy, sir.
No closure loops, right? But can you
Sir.
visualize the things? Let me visualization means, let us say that if I take this C, T, E. Now look at the joint C. How many members are connected there?
4, sir.
4, right? Now, if I
Yeah.
separate them at the joint, isn't it? Now, at this point, how many reactions will exist? How many internal forces? 3. At this point, 3. At this point, 3. At this point, 3. Isn't it?
Yes, sir.
Can you
Yes,
tell me how
sir.
can I find all these things? This is what the support is. Imagine if you know the support reactions, if these 3 are known, can I know these 3? If I know the support reaction, 3 reaction forces, can I find these 3 are known?
Yes, sir.
3 unknowns is unknown only now, sir. We cannot find, right? For the AC member, we have
Known, sir.
6 unknowns. So
Now, that's what I am saying. Let us assume that you know these 3 support reactions. Let us assume this. Let us assume that these 3 are known. Can I find these 3?
Yes, sir.
We can. Now, still, if I separated the joint, still how many I have to find? These 3 should be known. These 3 should be known. These 3 should be known, isn't it?
Yes, sir.
Now,
sir.
can you tell me how can I find these 3? Is there any thought? How can I find these three internal forces?
Now, opposite to this, we can find, sir.
At this member, how many at this joint, how many members are connected? 4. Then how can I directly take the
4,
opposite
sir.
to them? I cannot take directly opposite, isn't it? Why? Because if you are separating at one point, if only 2 members are existing, then you can say that if here 3 is there, then here you can tell me that okay, I'm taking the opposite of them. But here,
Okay.
at joint C, how many are connected? 4 different members are connected. Out of those, I am saying that these 3 can be known. But can you tell me, out of these 3, can you find anything? Come on, guys, just think about it. You can get an answer. What about the support D? Imagine if there is a force acting at this point. If I redraw this diagram, DC, force is acting, let us say 10 kilonewton. Can't I find these 3?
Yes, sir.
That means as it is a free end, there are no unknowns, isn't it? That means
0.
these forces I can find out it by using equilibrium equations. Similarly, look at CE. What is the type of support at E? Free end, isn't it? Similarly, as
Yes,
it is
sir.
a free end, if forces are acting like this, can't I find these 3? That means as it is a free end in D, I can find these 3. As because of free end at E, I can find these 3. And what about here? How can I find these three? If you add all these values, how much you should get? Somebody is saying? Yes, please. Whoever is saying?
Sir,
Yeah.
we see at the AC member at the junction point C, we have already find 3 unknowns right now, sir.
Can you please come again? Can you repeat it what you said?
Sir, along the member AC,
Yeah.
at the both end, we
Hmm.
have the known forces.
Yeah.
So the same applicable at the member, the code member at the point C also. So there is no unknown forces are here as of now.
No. Let me.
Sir, how it will be possible, sir? No possible, sir, at the D and
Just a second. I'm having some issues today. Okay. Now you are saying that again. Let me redraw them and we will clearly look into them. Let us see. Now tell me, here 3 unknown forces will exist, isn't it?
Yes, sir.
Now what is your question? Here 3 will develop and here also 3 will exist. Now what is your question about AC?
Yes, AC along this member AC,
Yeah.
already we have known forces.
Yeah,
So
this
if
is known.
the known forces at the point exists to C, the automatically the code member point also the known forces available now, sir.
How come? That's what I'm telling you. See, let us say that at this point I'm getting this as 10 kilonewton. Sorry, I'm not writing the unit. Here it is 20 kilonewton and here it is, let us say 40. Now tell me, what about the internal forces at this joint, whatever the internal forces at this point, and whatever the internal forces at this point? Can you tell me
so
these
no.
3 values? You are saying that no forces are acting at this end, that's why you are saying no forces.
Yes, sir. Because
No. Think about it generalized way. If
known
forces
forces.
are, I think, come again, sorry.
Known forces.
Known forces.
Yes. Because
What
at
are,
the two cantilever portion, we find the unknown forces already. So there is no need of finding out again.
yeah, that's what the point is. Because here, as D and E are the pre-end points, from the direction also you can find out the forces at point C and forces at point C in the member DC, forces at point C in the member CE. And then with the help of again this three and these three, we can find out the forces in this member by saying summation of forces are 0. If still I'm not clear, we'll discuss after the class, it seems. Except here, anybody is having the doubt?
Clear,
Sir,
sir.
please explain once, sir, please, sir.
I think there is so much overlapping happening because of the network issue or whatever it is. So just for today's class, please bear about it. Okay, I think, yeah, indeterminacy chapter is over. Now, let me come back to a simple problem again. As of now, you guys are very well aware of it. Now, what I would like to do is that I just want to write it down. How many unknown forces are there? How many unknown displacements are there? This is what I have to find out now. Okay. Now, let us say this is joint A, this is joint B. Now, in this case, let us say if we are talking about joint A, how many unknown forces are there? Anita, I will get back to you with that problem with an example. Let us continue with this. Suppose if you are looking at joint A, how many unknown forces are there?
One,
Two.
sir.
3.
Unknown forces. Let us assume you are talking about all possible cases.
All possible.
One, sir.
2.
All possible cases. Horizontal, vertical, or load 2, right? How many unknown displacements are there?
1.
1.
What is it?
1.
Rotation.
So at this point, along the
Yes, sir.
horizontal direction, deflection 0. Along vertical direction, deflection 0. And
Only rotate.
as resisting moment is not there, rotation is not equal to 0. As it is not equal to 0, this is what our unknown value. So this is what your unknown displacement at point A. Now, coming to joint B, how many unknown forces are there? One,
One.
that is vertical reaction. And how many unknown displacements?
2.
2.
2.
As resisting force will only develop in vertical direction by not allowing the vertical deflection. So vertical deflection at point B equal to 0, but displacement along x direction is allowed. Rotations are also allowed. So displacement along x is the unknown displacement, and rotation is also, right? Now, if you are looking at total entire beam AB, how many unknown forces are there? 3.
3.
As we know that these 3 can be solved by using equilibrium equations. That means the indeterminacy is 0. How many displacements are there?
3, sir.
Total unknown displacement 3, right? So this is what your kinematic indeterminacy. Before going to explain further, let me ask you a simple question. Let us say, if I draw the deflected shape of this beam, it might be somewhere shown like this. This displacement is also not known, right? We are, let us say, while considering the kinematic indeterminacy, what we are taking? We are taking the displacements at point A, we are taking displacements at point B. But why not in between the B? Have you ever got this doubt? Why we are taking only at the selected points, or we can say simply at the joints? Why not in between?
Support will resist it.
Any idea? Supports? We are taking only at the support, that why not at the in between the beam? They are also not known, but still we are considering only at the joint points. Why? Because have you guys taken finite element course?
No, sir.
Okay, you guys are in which year? Third year, you guys are in
Everybody has completed engineering, sir.
Okay. Finite element course you guys have not taken in your BTech course?
Finite element is an optional subject, sir. It was an elective.
Okay. So nobody offered it in your college.
Yes, sir.
Okay, now what happens is that in finite element, what we'll do is that, let us say, I have considering this as entire one element. If I'm considering this as entire one element, this is what the joints of the element. This is what we will call it as a nodal points. So what happens here is that whatever the displacements we will find out at the nodal points only. Displacements at the nodal points. If I consider it as one element, then I will say this is one nodal point, this is one nodal point. If I discrete it into two elements, this is element 1, this is element 2, this is my one nodal point, this is my second nodal point, and this is my third nodal point. So, depending upon the number of elements you are considering, at corresponding nodal point displacements can be obtained. After knowing this nodal point displacement, then what will we use that? We will assume shape function. That means, or we will consider it as a displacement function. So if you know the displacements between the nodal points, or if you know the displacements at the nodal points, you can find out the displacement in between them by using the displacement function with the help of the displacements at the nodal points. That means, if you have obtained the displacements at the nodal points, with the help of those nodal points, you can find out the displacement in between any point of the beam. That's why wherever if you are talking about the indeterminacy, always we will speak at the joint points, or simply we can also say it as a nodal points. So whenever if someone explain you what is kinematic indeterminacy, the first point you will say it as a independent. So always we have to see how many independent. That means if I talk about this simple beam, what about my, well, initially what I am doing? I am assuming that this can be known, this can be known, and this. If I can find out these three, with the help of these three, I can find out the displacement at any point in the beam. That means with the help of these three, I can find out at any point. So that's why, what is the independent degrees of freedom? 1, 2, 3. So no need to consider at any intermediate points. So whenever you are finding the kinematic indeterminacy, always you say independent degrees of freedom. As of now, clear about kinematic indeterminacy?
Sir.
Number of unknown independent degrees of freedom that are possible in a structure, or we will say independent degrees of freedoms required to represents the displaced position of the frame. I think hope it's clear about kinematic indeterminacy. So let us just start with start with the examples. Let us say this or in between. Let me tell you one more thing. Imagine if I apply a horizontal force P. Can you guys tell me what is the kinematic indeterminacy here? If I apply some force, what will happen? Will it resist, or rigid body motions are possible here?
Yes, sir.
Rigid body motion is possible, right? Let us assume that this beam has moved to somewhere here, just for the idealized case. Now tell me, what is the kinematic indeterminacy here? Come on, just think about it.
4, sir.
How
4,
many?
sir.
4, sir.
4.
Let me give you an option. 1, 2, 3, 4.
Nice options. 4, sir. 4, sir.
4. Everybody will agree?
No, sir. 3, sir.
Okay, somebody is saying 3. Any other options that you guys think about it? 3 and 4. Anybody goes for 1 and 2? Number 1, right? Nobody goes for it. Now tell me, whoever says it is 3, can you please tell me what are those 3? Let us say this is joint A and this is joint B. Whoever said it is 3, can I know what are those 3?
Sir, B will be 2.
And B will be 2 and
A will be 1.
at A will be 1. Okay, fine. Whoever said it is 4, can you tell me? Can you judge your answer? Can you justify your answer, please?
Which 2, sir?
No, sir.
Which support 2, sir?
Sorry?
Support A2 reaction, support B2.
See, don't get confused. We are talking about, yeah, at A you are getting 2 unknown displacements plus 2 unknown displacement. So you guys are saying 4.
Sir.
Anybody
Sir,
want to
2,
extend
sir.
your answers? Anybody
2,
else?
sir. 2, sir. 2, sir.
What are those 2?
Sir, only that horizontal reaction only, sir.
Yeah,
So it is displacement technique.
displacement at?
Sir, due to horizontal force only, sir.
Yeah, due to horizontal force. Displacement at what points?
At
Displacement at
A1 and B1.
Okay. And now finally you guys are left with option 1. Anybody want to take this option 1? Now see, the first thing is, imagine this we have already discussed. As horizontal force is applied here, which type of force it is to the member AB? Is it a axial force or it will be a transverse force?
Axial force. Sir.
Axial force. That means because of the axial force, which type of effects will act on the beam?
Horizontal force only.
Only horizontal will exist. So
Yeah.
there is no point of vertical displacement and there
Or
is no
moment.
point of rotation.
Yes, sir.
So only there is a possibility of getting horizontal displacements, isn't it? Now tell me, whatever the rigid, is it a rigid body motion or not?
Rigid body motion, sir.
If it is a rigid body motion, let us say from the initial point, let us say it is displaced by an amount delta. And can you tell me what is this amount? What is this deflection? Because of the applied force, if it has moved to the point delta, how much B should have moved? What is meant by rigid body motion? Initially, it is there at one point and it is moved to some other point. That's it, right? Here also it will be delta. If this delta is known, don't I know this delta?
Yes, sir.
Both are
Yes, sir.
same.
Yes, sir.
Now, how many unknown? That's why I'm telling you how many independent displacements. In this case, even though A has moved by an amount delta, B is also have moved an amount delta. But still,
1.
tell me what is the indeterminacy? 1.
1, sir.
Why? Because we will always speak about the independent degrees of freedom. So whenever you guys are thinking about kinematic indeterminacy, you guys have to think in your mind that you have to take the independent.
Sir, sir.
Now, is it fine?
Clear,
It's
sir.
clear, right? Now,
Clear,
let
sir.
me give you, let us solve one more problem. First of all, tell me, see, one more thing in the exam, people or students usually get confused is if they ask this static indeterminacy, we might submit kinematic indeterminacy. So let us, while solving the problem, let us clear our minds. If it is kinematic, we have to think about the rotation or unknown displacements. If you are talking about the static indeterminacy, we have to think about the forces. Now, let us say this is A, B, and C. Now tell me, what is the static indeterminacy?
Mm,
2, sir.
two, sir.
Static indeterminacy.
Sir, 1, sir.
One, sir.
How come you guys are saying 2? How many reactions will exist at point A? 2.
Two, sir.
Unknown forces. Here I am writing unknown forces. At point B, how many will exist?
One, sir.
1. At point C, how many will exist?
One, sir.
1. So total how many forces?
Four.
4 unknown
Plus
forces,
three.
3
Four plus
equilibrium equations. So total static indeterminacy is 1. Now coming about decay, kinematic indeterminacy. Now tell me, at A, how many will exist?
One.
kinematic indeterminacy. Now we have to think about
Five.
displacements.
Yes, sir. One, sir.
Five.
At A, one, sir.
At A1, what is it? Rotation.
Theta.
And at B,
Theta
let's
and
say theta A. And at B, how many are possible?
Two, sir. At B2, sir.
At
theta
B2,
and rotation.
At B2, sir. Two, sir.
what are they?
Rotation and
Rotation
Rotation
and
at B
horizontal force,
and
sir.
also horizontal displacement at B.
And also C, that two, sir.
At C2, what are they? Rotation at
Rotation
point
and
C
horizontal.
and horizontal displacement at C.
Yes, sir. Yes, sir.
Now total, what is the kinematic indeterminacy?
Five, sir.
1, 2, 3, 4, 5,
Five.
9, 5, sorry, 5. Now, if I can tell you that beams are axially rigid, what does it mean? What is mean by axially rigid?
No displacement on horizontal.
Let us, before coming to discussing this, let me give you one more example. The same example I will consider. Now you guys tell me, how many unknown forces will exist at point A?
2, sir.
Is it 2? Everybody will agree to it?
Two, sir. Sir,
What
DK
is-
or DS, sir.
What is the difference? See the difference between this case and this case. What is the difference? I have given it to you guys.
Vertical loading is
That means what is the
A
difference?
will be one, sir.
This
One,
we
one,
have
sir.
to general case, this case you have to idealize, but
Vertical
this
loads.
you have to think with respect to the given loading. So how many reactions will exist here?
Yes, sir.
One, sir. At A.
A one, sir.
Vertical reaction.
A one.
And here? And
B
here?
one, sir. C one, sir.
Total how many reactions?
Three, sir. Three
Three.
ones, three.
How many equilibrium equations?
3.
Two.
So this is where we should
Two.
not two. What
sir,
are they?
two.
We are
sir.
not considering the horizontal, so I will consider only summation along y0
One.
and summation of moment 0. 3
sir.
minus 2,
Equal
how
to
many? 1.
One.
Is there any change in the indeterminacy, static indeterminacy here? No, right? Here also 1 and the previous case is also
No,
1.
sir.
Now tell me, how
Same,
many
same.
unknown displacements will exist at point 8? How
One,
many
sir.
unknown displacements? One, what is it? Rotation at
One,
A.
one, the, sir. One, the, sir.
And at
Yes,
B,
sir.
how many unknown displacements are possible?
1, sir.
1 or 2?
1, sir.
Why?
One,
Because
sir.
as horizontal
One,
loads are not applied,
One, sir. One, sir.
1. As horizontal
Yes, sir.
forces are not there, there is no point of horizontal displacement.
Moment only, sir.
So only rotations are possible.
Moment only, sir.
Rotations are different, movements are different. So, whilst we can just think about in our mind. Similarly, at point C, how many unknown displacements are possible?
1, sir.
One, sir.
What is it? Rotation at point C. Now, what is the kinematic indeterminacy?
Three, sir.
3, sir.
3. Now, here, what is the kinematic indeterminacy? 5.
Five, sir.
Here, what is the kinematic indeterminacy? 3.
Three,
Now,
sir.
calmly look about where the difference has come here. See these 3
At vertical loads.
and then see these 3. Sorry, see these 3. What are the degrees of freedom or what are the displacements that you have ignored from here?
Axial, sir.
What are the displacement that you have guys have ignored?
Actual force.
Axial, right?
actual
Theta B
display.
and theta C. So what happens in generally, whatever the structures that are existing in reality, if it is a frame type of structure, then the axial rigidity. How to define the axial rigidity? What is the flexural rigidity?
EI, sir.
EI. What is the axial rigidity?
AI, sir.
AE, sir.
AE, sir.
AE.
AE, sorry, AE.
Right. Suppose if I want to find out the deflection due to flexure, then what is the formula then? You might have some integral m over dx divided by ei. If your ei is so large, then what happens to your deflection? It will
Decrease.
be 0. If it is
Decrease, sir.
infinity, then it is 0, right? Rigidity means that these values are so high such that you don't have any deflection. That will be very, very, very minute and you can be neglected. That means if these are axially rigid member, that means there won't be any axial deflection in the member AB. There won't be any axial deflection in the member BC. That means out of these 5, if these are axially rigid, how many I can neglect it? 2.
2.
That's why here it is 5 minus 2, that is 3. Are you getting the same answer or not? Here also.
Yes, sir.
If the specific loading is given, according to that we can find out. If not, if they are axially rigid, then also you can say, isn't it? So this is what the difference that we can make it. As of now, any doubt?
No, sir.
All right. Now, what I want you guys tell me. What is the, I think you guys can quickly tell me what is the static indeterminacy without solving anything.
2, sir.
Unknown.
2, sir. 2.
2, right? Now, you guys don't be in a hurry. If you guys else the quickly answer the answer, then you guys won't get any points. So just try to tell me, think about it and tell me what is the kinematic indeterminacy and also what is the kinematic indeterminacy if the members are axially rigid. Okay, just take 2 minutes of time and then solve it.
Kinematic indeterminacy 1, sir. Only at the point A, we have only rotation.
7, sir. It's
Because
not.
actually rigid.
It's actually rigid. Sir,
Sir,
Yeah, guys, sorry. Yeah, tell me what is the indeterminacy?
1, sir. 1.
1.
7.
Rotation at A, theta A. Kinematic indeterminacy, sir.
Theta A. And any other answers? Everybody will agree with the point 1.
Yes, sir. 1 only, sir. Because it
Now
has
tell
been
me,
zero.
here why I am considering theta B? Why you have considered theta B? Just because you are having the support here?
Polar support. Rotation.
Here what I'm asking is that you have considered only theta A, isn't it? You
Yes, sir.
guys have not considered a displacement at point B, at point C. Now my question is, why you guys have ignored the unknown displacements at B and at C? Here, why you guys have considered B and C also? What is the difference?
It will be beam on the, it is beam, sir. It will be frame, sir.
In a frames? So here, see, wherever there is a transition, that means wherever there is a
Both
change
A
in
and
the
B will be same.
sorry, ma, I think your voice is not clearly audible. So at point A, we have to consider. Similarly, at B, the transition is happening in the member, or member orientation is changing. So wherever there is a change in the orientation, we have to consider the displacements at that point also. So at this point B also you have to consider unknown displacements. At this point C also you have to consider, and at point D also you have to consider. At point D, as it is a fixed support, every value is 0. Now at point B, how many unknown displacements might exist?
Theta P and theta C, yes, sir.
Now I am considering a point in a 2D frame. Again, I am telling you, if you are considering a point in a 2D structure,
Sir, two possible, sir. Theta B, theta PC. Two cases are possible.
here I am not talking about, I am not given any loading, right? There might be horizontal loads present, there might be vertical loads also present there. If it is a 2D point, if you are considering a point in 2D, rotation at B possible,
Theta
deflection
C.
along horizontal possible, deflection along vertical possible. At point C similarly, deflection along X is possible, deflection along Y is possible, and also there will be rotation. So total how many? At point
1,
B, 3,
2,
at point C, 3,
4.
1 plus 3 plus 3. How many?
3 plus.
Is it clear? What are those 7? Any doubt?
Sir,
Yes, sir. Clear, sir.
BA and the DC is equal length, sir. Are we
B,
assuming like that? BA and CD is equal length.
there might be in different length also, no matter. Even the D extends to here. How does it matter? Here I'll take 1 point and here I'll take 1 point. In between I can find out by using displacement function. Doesn't matter. Okay, guys, any doubt in what are those 7? Is it clear?
Clear, sir.
You guys are sure, right? What are those 7? Once again, I'm asking, as I'm not, why I'm asking so many times is that whatever you guys are speaking, it's not clearly audible for me. That's why I don't know whether I'm completely satisfying your questions or not. So that's fine. If you guys don't have any doubt, now tell me, if they are axially rigid, what are those values?
Sir, at the point A, we have only one theta A.
5.
Then at the point theta B, then theta C. And if it is actually rigid, means if we have lateral load, theta del X will be there, no, sir. Am I right?
Sir, 4, sir. Answer. 4, sir.
4. How? What are those 4?
Point A, 1 theta A.
See, as of now, I think by simply, I think you guys might have already studied essay, so it will be very easy to give the answer for this. But the point is, whatever the value you are saying, if you can visualize those values in the diagram, then that is what you guys are needed. Those who are saying 4, can you guys please tell me what are those 4?
So theta A,
Yeah, right.
theta B, theta C,
Right. Theta B.
Theta C with 2, sir. 2, sir.
then
And
del
deflection.
X, sir. Then del X.
Then del X of what?
Del X
To deform displacement,
displacements.
sir.
Now tell me why I should not consider delta Y.
So delta Y at the point B, BA, it would be the axial deformation, but the member is axially rigid.
Won't be developed on delta O.
Any other options that you guys want to discuss about this? Everybody agrees with 4, or you guys want to change your answer?
Two, sir.
What are those 2?
Sir, theta A, theta B, theta C, same only.
Hey, how come they are same?
Same rotation.
No. They won't be. They will be different, obviously. And those who gave correct answer for this, what I am expecting from them is to I think I'm making it so much complicated, right? Instead, I can do further simplify. Guys, don't think that we are taking too much time. It's just we are understanding the problems, okay? Now, what is the kinematic indeterminacy? I will come to the previous problem after completion of this. Okay, so don't worry, those guys didn't understand, that's fine. Now tell me, what about here decay? Tell me in general, first of all, I'm not talking about axially rigid.
Five, sir. General.
Forget about axially rigid, now tell me the answer. At point C,
So
what is
five,
the independent degrees of
Five.
freedom?
5.
5, sir.
At C is 0. At B, how many?
3, sir.
Rotation,
3, sir.
horizontal, vertical. And at point A, how many?
2, sir.
2, sir.
Vertical and rotation.
Rotation.
5. Now tell me, if they are axially rigid,
Okay.
what is the kinematic indeterminacy?
Mm,
3, sir.
3.
Sir.
Everybody will agree? What are those 3? Can you guys please explain me?
B.
Come on, guys. Rotations, you can directly tell me. What are they? I can say theta A and
Theta A,
yeah.
theta
And
B,
what about the another one?
different
Along
along
AB, we have a displacement, sir.
Which displacement you are talking about?
At the point A, we have a
Let me give you
displacement
the direction X and Y.
Y direction, we have a displacement.
Why we are considering only at Y? Why can't I consider delta Y at B or delta X at B?
Since the member is actually loaded at the point,
Yeah.
that is why EC and BA, we don't have any axial displacements.
We don't have any axial displacement. Okay, that means I can say dx, but what about delta Y?
Delta Y is the displacement along the member BA, so we are not considering an answer.
Yeah, whenever you are speaking delta Y, yeah, here it will be delta Y, then here it is also delta Y. Now, let me explain this problem first of all, and then it will be clear. Members are axially rigid means member might move to another place, just like this example. Just like this exam, where is it? Sorry guys, sorry. Yeah, just like in this example, as they are axially rigid, then what happens? It might move to one place. If it has moved to one place, then at both ends, the unknown displacement can be defined it by using only one value. with the same logic, let me explain this problem. Here it is. Obviously, rotation will exist here, rotation will exist here, rotation will exist here. Okay. Now let me start with point A. What we have discussed? We have discussed that members are axially rigid. Now tell me, is there what is the vertical displacement at point A? What is the axial force direction for the member AB?
0, sir.
The axial force direction for the member AB is vertical direction. So A, what is the vertical deflection at point A? 0. Now we are saying that member is axially rigid. That means if this point moves, then point B will also move by the same amount. But what happens at point A, as there is a support, that will not allow any vertical deflection. In the vertical means vertical represents the axial direction here. That's why as the vertical deflection is, just wait on a second, guys. Just 2 minutes. Yeah, sorry. So there is no vertical displacement at point A, and similarly there is no vertical displacement at point B. So here previously what we have considered, horizontal we have considered, vertical we have considered, rotation we have considered. As this vertical is equal to 0, as this is axially rigid, vertical deflection at point B is also not possible. So that's why out of these three, what I can eliminate? I can eliminate this vertical direction. Now, similarly, what is the vertical displacement at point D? Similarly, this point D also won't allow any vertical deflection because it is a fixed support. So as the vertical displacement at this point is 0, what is the vertical displacement at point C?
No, sir.
This one initially we have considered again horizontal, vertical, and rotation. But as this support will not allow any vertical deflection because of the axial rigidity, vertical deflection at point C is also equal to 0. That's why what I will eliminate? I will eliminate this vertical too. Now how many we have left with? Total 1, 2, 3, 4, 5. Now again, what is the axial direction for member AC? Horizontal. Right.
Horizontal.
Is there any support at point B that
No.
will not allow any horizontal displacements? No. Just like if you see at point A, as it is a support, it will not allow any vertical deflection. But at point B, is there any such support like that?
No, sir.
No. Right? So that's why
Yes,
deflection, horizontal deflection might possible at point B. Similarly, is there any support reaction existing at point C that will not allow any deflection? No, right? That means deflection at B is also possible. Horizontal deflection at C is also possible. But what we are saying, these members are axially rigid. What does it mean? If this point has moved by an amount delta, point C also will move by an amount delta. That means rotation at A I will consider, rotation at B I will consider, rotation at C I will consider. In addition to 3, out of these 2, then what I will consider? I will consider 1 plus 1. That is either horizontal deflection at B or horizontal deflection at C. That's why total how many? 4. Is it clear? Any doubt?
Yes, sir.
What if I draw the deflected shape here? The deflected shape might like this. So From here to here, what is the amount? Delta. From here to here, what is the amount? Delta. What happens if I keep a support like this? Now, can you tell me what is the answer? If I have created an additional support at point B, can you guys tell me what is the answer?
Then
What
we
is the
don't have
kinematic
the
indeterminacy?
three only, sir. All are
Three,
rotation
sir.
only.
Only all are rotations.
Initially for minus, it will not allow any horizontal displacement. If it is not moving, this one will also not move. So out of those four, again, I will neglect one. So total how many? Rotation at A, rotation at B, and rotation at C. If I see the reflected shape, how it will be? It will be like this. Clear? Is it clear about kinematic indeterminacy?
Yes, sir. Clear, sir.
Now,
Yes, sir.
now tell me here. With the same example, what I can consider? What is the axial direction for member BC?
Horizontal, sir.
Horizontal. This will it allow any horizontal deflection?
No.
That's why
No, sir.
horizontal
No, sir.
deflection is not possible. Horizontal deflection at B is also not possible. What is the vertical direction? Axial direction for member AB? Vertical.
Correct, sir.
Point A allows the vertical deflection or not?
Yes,
It
sir.
will allow. That means point B will also move by the same amount. So that's why what are the unknowns? Theta A, theta B. In addition to it, delta Y. So there is a formula like, if you want to consider axially rigid members, what you can do is that total degree indeterminacy minus number of members. So initially we have counted as 5. How many members are existing? 2.
2 numbers.
So 5 minus 2, 3.
3 only.
My point is that instead of blindly following this, you should also have to
Sir,
understand
sorry.
what are those.
Sir,
Yeah,
sorry.
please.
Sir, del Y I am not getting. Could you please explain once again?
Yeah. Now, what is the axial force direction for member AB? Y direction, according to it, right?
Yes, sir.
Now, what is the type of support at B? Like, what is the type of joint? It is a rigid joint. Usually, we will consider, right?
Yes, rigid joints.
Before that, what is mean by rigid joint?
Rigid joint means
I should have guys tell you. Rigid joint means that all the members will rotate at the same rotation. That means here how many members are connected? 2. If it is a rigid joint, this rotation, if it is theta, this rotation is also theta. If it is a rigid joint, all the members are rotated by the same amount. Now you can tell me, as it is a rigid joint, rotation is also possible. At
Yes,
this
sir.
joint, horizontal deflection is possible. Vertical deflection is also possible, right?
Yes, sir.
Now we have seen that this is 0 because of the fixed support. Here, what is
Yes.
the axial force direction? 0. As it
Yes.
is axially rigid, this one also will not have any horizontal. So this is 0. Now at point B, vertical deflection is possible,
Yes, sir.
right? Similarly, at point A,
This del X is axial deformation or what, sir?
yeah, I see for the member AB, what is the axial deformation direction?
AB is along Y direction, sir.
Along Y direction. For member BC,
BC
X.
along X direction.
that's why if you are looking for member BC, for axial deformations, we have talked about along X direction displacements.
So del X is axial deformation. Okay.
Yeah, now for you it's clear, right?
Yes, sir.
Okay then. Now with this, before going to find out something, I will write type of joint, unknown displacements I want to see. Let me write it down nicely so that it might be helpful. Is the size of the letters are okay?
Okay, sir.
Thank you. Sorry guys, today there is a power cut at my place around 8:30. So for today class, we might have to end up at 8:30. Hope you guys are fine with it. Okay. Now,
Okay, sir.
let me start with rigid joint. What does the symbol means? Continuous, right? Forget about them. If it is a rigid joint, additional equations that you will come to know after. There are no additional equations for rigid support. How many unknown displacements are possible if it is a rigid joint?
No possible for
No possible. Zero.
Unknown displacement, rigid joint. It
zero.
is not a support.
Three, sir.
3. If
Three,
it is a
sir.
three case, 3. What are they? Delta x,
Delta
delta
y.
y, and theta.
Theta.
Rotation.
Rotation.
If I am talking about 3D, how many unknown displacements will exist? Here I am
Six, sir.
getting into the 3D also. What are they? Delta x, delta y,
No.
delta x,
Delta
y,
is
theta y,
Theta y.
theta z.
theta is that.
Now, what if there is a hinge joint or pin connection, hinge joint? What is the property of the hinge?
There is no
Zero.
moment.
Moments are zero, right? How many additional equations are possible if it is a hinge joint?
Two
Here, how many
Two,
members
sir.
are connected?
2 members.
Two members.
Two members
members,
are
sir.
connected. Then, how many additional equations are possible?
1.
One sir, one.
That is, moment at that point is equal to 0. Now, tell me, how many unknown displacements are possible? What is the difference between these two? Can you tell me what is the best example for hinge joint in our body parts?
Elbow.
Anything, any part you take it. They can freely rotate, isn't it? Now, how many unknown displacements are possible? Even if you take the elbow joint, they can rotate by different amount. What you can see, will they move by the different value of displacement? Like one have moved in downward and another have moved down upward.
Two possible.
So if it is a hinge, first thing is that it is not resisting any movement, isn't it? If it is
Yes,
not
sir.
resisting any movement, then because of the rotation movement, which are rotations are possible. As resisting movements are not there, then rotations of the members might be different. That means for this, the member rotation, if it is like this, theta 1, and for the member 2, rotation may be different, that is theta 2. But what about if it is a rigid joint? They will be rotated by the same amount, theta 1 and theta 1. So, displacement along x direction is possible, displacement along y direction is possible. In addition to it, what happens? Rotation at 1 and rotation at 2. So total how many here?
4.
Now did you find the difference here and here? Now, similarly, if there is a hinge joint like this, how many additional equations are possible? Again, I am talking about this is in 2D. How many members are connected? 3.
3 members.
3 minus 1, 2. We have already seen y2. And now tell me, how many unknown displacements are possible? Delta x is possible. Delta y is possible.
Delta y.
How many rotations are possible there? How many members are connected?
3, sir.
3.
Three, sir. 3.
As it is a hinge, 3
Three
different rotations are possible. So that's why.
5.
So total 5.
5.
Here I have considered 3. There might be 4, there might be 5, there might be 6. It doesn't matter. You know the logic, isn't it? Is it clear?
Clear, sir.
Now, if I have considered the same hinge, but I have considered in 3D direction, that means there is a hinge in 3D frame. Can you tell me how many additional equations are possible? Now, this is where you have to apply the logic.
Del X, del Y.
What is the question? How many?
2, sir.
What is my question? How many additional equations are possible? See,
2, sir.
if it is 2D, how many additional equations? 1. Can you tell me what is this equation?
1, sir.
What is the equation? Moment, if this is point C, MC is equal to 0.
0.
Now, what happens if it is in 3D?
2,
What is
sir.
the change that you will observe? 2.
2,
If it is 2,
2,
what are
sir.
they?
Moment, rotation.
If it is a hinge, resisting movement will not be there. Resisting movement is 0. What is the difference between 2D and 3D? In a 2D, how many movements are possible? 1.
One moment.
In a 3D, how many movements directions are possible?
3 moment.
3.
That means what you can say, movement at this point along x direction is 0, along y direction is equal to 0, along
0.
z equal to 0. Total how many are possible?
3.
What are those? Movement along x equal to 0, movement along y equal to 0, movement along z is equal to 0. Now with the same logic, can you guys tell me how many unknown displacements will be there? Now, first of all, come to the displacements. It is a 3D. So how many displacements are possible?
3.
3, sir.
Del X,
Delta X,
Del X,
delta y,
del Y, del Z.
delta z. Now, think of about x direction. Along x direction, how many rotations are possible?
3, sir.
Along the x direction, I am talking about theta x.
2, sir.
For this member, theta x will be different. For this member, theta x will be different. So, theta x for member 1, theta x for member 2. Similarly, for member y, along y direction, sorry.
Theta
Rotation for
Y1,
member
theta
1.
Y2.
Similarly, along z direction, theta z1, theta z2. So, total how many?
6.
3 plus
9, sir.
9, sir.
9. Is it clear? Now tell me, in this case, if it is 3D, how many additional equations are possible? If it is 2D, we are taking 1. If it is 3D, multiplied by number of directions. How many number of directions? 3. Just apply the
3.
same logic.
3 into 2, 6, sir.
3 into 2. You have to visualize those 6. Then only you can solve each and every problem. Now similarly, how many unknown displacements? Delta x, delta y, delta z common. Any doubt?
No, sir.
Now think about x direction. Along x direction, how many rotations are possible?
3.
Like that, how many directions are there?
3 directions.
So if you take along x direction, 3 different rotations are
Totally
possible
12,
along
sir.
x. If you take y, along y also 3 different rotations. If you take z, along z also 3 different rotations. So total 3 times 3 rotations. 3 per directions, x, y, z. That will be equal to 9. So total how many? Any doubt as of now? Or is it very much clear?
Clear, sir.
Yeah, this is okay.
Everybody. I'm need from everybody.
Clear, sir.
Clear, sir.
Clear, sir.
Sir,
Yeah.
one doubt.
Yeah.
Can you explain about degree of indeterminacy, internal and external?
Explain about what?
Internal degree of indeterminacy, external degree of indeterminacy.
You want what is internal indeterminacy and what is external indeterminacy?
Yes, sir. Yes, sir.
So internal is just be possible because of the arrangement of the members. And external indeterminacy is possible because of the support reactions. Now, if I take a simple frame like this, if I talk about external indeterminacy, first I will look at the supports. Here, 3 unknown reactions are possible. Here, 3 unknown reactions are possible. So total, if I take free body diagram of entire structure, 6 unknowns, 3 equilibrium equations. So 3 unknowns are there, isn't it?
Okay.
Now
Sir.
the point is, now let us assume that you know the support reactions. If you
Yes, sir.
know the support reactions, can you find out all the internal forces in the members or not? This
Yes,
point,
sir.
we will not discuss it for beams generally. Why? Because the beams are oriented along one direction. So if you resolve or if you separate beam at a point, those reactions will be opposite to each other. That's why for beams, generally we won't talk about internal indeterminacy. But if you see, look at this joint. If you look at the joint A, and if I separate at that point, in one case, let us assume that 3 members are connected. In another case, let us assume that only 2 members are connected. And again, I am separating them. At this point, how many internal forces are possible? 3.
Yes,
At
sir.
this point, how many internal forces are possible? 3.
3.
At this point, how many are possible? 3.
3.
Similarly, if 2 members are connected, at this point, how many are possible? 3.
3.
At this point, how many are possible? 3.
3.
Now tell me, if I know these 3, can I know this or not?
Yes, sir.
Yes, sir.
Why? If this is in a horizontal direction, then this I will take it as a left. If it is upward, this I can take it as a downward. If it is clockwise, there I will take it as a anti-clockwise. Isn't it?
Yes, sir. Yes, sir.
Similarly, let us assume that at this joint, I know these forces. Horizontal force is 10, downward is 20, and rotation is 40. Now the point is, if I know these 3, can I find either this one or this one? Can I or cannot? Can
Yes,
I
sir.
apply the same logic here?
Yes, sir. We can, sir.
We cannot here. Why? Because here we are just taking simply opposite reactions. But here also 3 will be possible. Here also 3 will be possible. What is the condition we talk about? At that joint, if we talk about, we'll say summation of x 0, we'll say summation of y 0, and say
Moment 0.
0. Now, because of these 3, if I take here, if I'm considering on the right side, if I add forces along this direction, they should be 0. How can I make them is equal to 0? If I'm acting 10 as right side, if I consider at this point left side 10, then only if you sum it up, then you will get 0. But here what happens? Instead of single point, we may get horizontal force here, and we may have horizontal force here. Let us say this is delta x1, this is delta x2. If I apply that condition, delta fx, what I will get? At this joint, what is the x direction force? 10. At this node, what is the x direction force? Delta x1. In this, what is the x force direction? Delta x2. If I add those two, how much I'll get? 0.
Equal to 0.
If I know this one, can I find out this one or not?
Yes, sir.
Right? Why? Because if I add these three, this should be equal to 0. Similarly, if I write it down along y direction, if I write it down along y direction, what I will get? 20 plus force along y1 plus force along y2, that will be 0. If I
0.
know this one, can I find out this or not?
Yes, sir.
Similarly, if I write down for a moment, again, if I know one, I can find one. That means from this equation, I need one unknown. From this equation, I need one unknown. And from this, I need one unknown. That means you can say that out of this, either these three or these three, if I know any one of these three, then I can find out the another three by using summations.
Okay, sir, but how we are finding the first one, sir? FX1.
Yeah, that's what the question, that if we solve the problem, that we will come to know. But if I can tell it to you, again, it will be a big problem. It will take so much time. So we'll discuss
Okay.
all those things later in problems. But as of now, you guys just have to get the idea how it will be.
Okay.
I think I have tried all possible way by explain with some example problem. But these type of problems we cannot, isn't it? We cannot able to. We cannot solve this big problem, and I can show it to you how they can be known. But it's clear, right?
Yes, sir.
Internal
Clear,
reactions.
sir. Clear.
Yeah. Okay.
Yeah, okay, then I think we should wind up here. Okay. At any time,
Yeah.
power might come.
Sir,
Okay. Yeah, please.
sir, in the last problem, you have mentioned some del X. Could you go to the previous slide, sir?
No, this is not delta, this is force, okay.
No, not this one, sir. Before 3 to 4 slides. The L-shaped, remember, this is the one. L-shaped, remember. Here you have written del Y right now, sir.
Yeah.
This actually it will not come. It will not come.
Maybe along maybe we don't have any displacements, right? Del Y equal to 0. Then how it is coming del Y?
Where del y is equal to 0 in this case?
In this case, along A, at the point A, we don't have any displacements, right?
It is a roller support. It is placed along which direction? Roller support. Roller is oriented along y direction. So y direction is possible, right?
Yes, sir. Yes, sir. Yes, sir.
Yeah. If it is fixed, according to you, if it is spin,
Yes.
this is also equal to 0, then you will get only 2.
You are right.
Yeah. Fine.
Yes, sir.
Okay, then thank you guys. Thank you for having me today. Bye.
Thank you, sir.
Thank you, sir.
Thank you.
Thank you, sir.